Mustafa Alaoune, the head of Science and Math Department. I would like to welcome you in the first ever AIS Virtual Science Fair. This event will highlight few of AIS top scientists. They will share their experiments with you. Science experiments are always fraught with challenges and step-backs, but these students have taken an extra challenge to complete the entire project while being quarantined. We have a very exciting show for you today. Please don't forget to vote for your best project. Use the link in the chat box.
Respective AIS community, Assalamu alaikum and a very good afternoon to you all. Every year, Arab International Schools arrange a science fair in its premises to post up the creative minds and innovation of the students. Even though we are stuck in our homes during this pandemic, it didn't stop us from pushing our students' innovating minds forward. So, for this first time, AIS has arranged Virtual Science Fair 2021, and I'm glad you could be a part of it. I'm your host, Rima Al-Ataibi from grade 10, and let's start by listening to our national anthem.
المجد والعليا مجدي لخالق السماء وارفع الخفاق اخضر يحمل النور المسطر رددي الله اكبر يا موطني قد عشت فخر المسلمين عاش الملك للعلم والوطن.
Now we have a special video presented by Rasil Al-Ahmadi from grade 10. And now, let's start to enjoy our students' creative projects. Don't forget to vote for your best project by scanning the QR code shown on the screen, or click at the link sent in the chat box. Let's start by a parachute project by Ragad Al-Aql from grade 11, supervised by Mrs. Ariba.
Hello, my name is Ragad, and in this video I'll be showing you how I made a parachute. So first of all, I cut off both these sides, then I fold it into a rectangle, then a square, then a triangle, then an isosceles triangle, then into a smaller triangle, so when I cut it off it becomes a circular shape, as you can see right here. Then using a ruler, I measure for every 60 degrees angle, I put a mark, and using tape I cover those marks so it becomes stronger. Then I put a hole inside those marks and then put a thread inside the hole, and then I add the figure, and here's the finishing product.
Don't forget to vote for her at number 1.
Thank you for watching.
Making a Flute by Amal Matar from grade 12, supervised by Miss Ariba. Vote for her at number 12. Charles Law by Dima Suwayiq, Grade 12. Sultana from Grade 4, who did the project of water xylophone, supervised by Mrs. Naha.
Now you can hear the difference.
Hello, today's experiment is to magically blow up a balloon. And chemistry says vinegar and baking soda experiment. So, things you will need is balloons, spoon, funnel, plastic bottles, vinegar, and baking soda. So, shall we begin? First step is to pour some vinegar in the plastic bottles. Yeah. I'll add 1/3 of vinegar. Yeah. In here, 2/3 of vinegar. That's not focused. Yeah. Okay. And lastly, 1 cup. Okay, great. First step is done. Second step is to add baking soda in the balloons. Great. Then I will add 3 spoons. Okay, done. The next balloon is 2 spoons only. And lastly, 1 spoon. There's just few of them, so. Okay, first step and second are done. Let's just add these. Okay. I just opened this from the cap. Yeah. So let's just gently put it on the top. Don't let the baking soda, yeah, look. Don't let the baking soda in. Yeah. So the other one, same, gently. Okay, great. And same also. Let me just, yeah. So now the chemical reaction will begin. So let's just pour this, not this one. See? happening is because baking soda and vinegar that creates acid-base reaction, and two chemicals work together to create gas, carbon dioxide. Sorry. So gases need space to more, therefore it moves into the balloon, and you can see the bubbles here. You can see the bubbles in here, and so that's why it expands and inflates. So yeah, and we just yeah. So thanks for your time and watching this video, and goodbye.
And now with the recycling, how to make a jewelry box by Lin Attar from grade 10, supervised
So
by
today I'm going to be teaching you how to make a functional jewelry box with household items that can be reused in a functional way. So first up, you're going to need a cardboard box. This will be the base of our jewelry box. And then you're going to need colored markers or markers in general to decorate the box to however you want. And then you're just going to need jewelry of your choice to fill the box with when you're done. So now you can decorate the box to any way you like, and then voila, you have a perfectly functional jewelry box. Recycling makes our environment cleaner, conserves materials, saves energy, and reduces the amount of garbage that ends up in landfills. In this case, burning the same amount of cardboard would generate around 750 kilograms of carbon dioxide. Recycling will also save 65% of the energy we need to produce new cardboard and reduces water pollution by 35%.
And now for the recycling project by Liana Al-Wagdani from grade 10, supervised by Mrs. Arisha.
Hey, I'm Liana, and today I'll be showing you how I recycle and reuse these. I'll be using our gift wrappers, pencil, scissors, and after I proceeded to cut the cereal boxes just like that, I'll be covering them both with the gift wrappers.
And now for the carbon atom project done by Alina Al-Garni, grade 5, supervised by Mrs. Naha.
My name is Alien. This is my project about carbon atom. Atom is the small part, and carbon is 6 electron and 6 neutron and 6 proton. Then I draw a circle, big circle and a small circle. We have a negative. I draw of them 6, and we have a proton and neutron. Neutron have nothing, and proton is positive. Thank you.
Density by Shadon from grade 7, supervised by Mrs. Arisha.
Hi Miss, how are you? I hope you are okay. Today I am going to represent the science project about 8 layers of density. I am going to use a large glass, syringe, honey, corn syrup, 100% maple syrup, whole milk, dish soap, water, vegetable oil, rubbing alcohol. First I am going to use the honey, but we have to be very careful while pouring it, and you have to be very slowly and pouring it and not let it touch the sides in the large glass. Second, we are going to use the corn syrup, but it is like honey. We have to pour it very slowly and very carefully and not make it touch the sides. Third, we are going to use the 100% maple syrup, but it is the same as the honey and corn syrup. We have to pour it very slowly and very carefully. Now, to layer the rest of the liquids in the large glass, you need to use the syringe. Be careful and you need to be very slowly. With the dish soap, also be careful and go very slowly. Now water. Now the vegetable oil. Finally, the rubbing alcohol. The density is the volume or mass in a subject, and the liquids that will sink have higher density, and the liquids that will float have lower density. I hope that you enjoyed watching the video. Thank you. Goodbye.
Static Electricity by Ragad al-Sharif from grade 10, supervised by Mrs. Ariba. And now that's my project from grade 10. It's about the nucleus, supervised by Mrs. Sara Al-Khouli. Good afternoon, everyone. I hope you're all doing well. Today I'll talk about the nucleus, presented by me, Reem Al-Atabi. Today I'll talk about the definition of the nucleus, the roles of the nucleus, and the parts of the nucleus, and the organisms that possess a nuclear membrane. First of all, let's start by defining the nucleus, which is a membrane-enclosed structure that contains genetic materials in the form of DNA. And what actually holds that DNA is the chromatin. We will talk about it more. As the nucleus controls the most important thing in the whole cell, which is the DNA, it also controls most of the cell processes and activities. And now let's talk about the roles. The cell nucleus is the site of many important biological functions of the eukaryotic cell. These processes include transcription, replication, splicing, and ribosome biogenesis. these are the parts of the nucleus. That's the chromatin that I just talked about, nucleolus, nuclear pores, and the nuclear envelope. So the nucleolus is where the assembly of ribosomes begins, while the chromatin is a thread-like structure that contains the genetic material or the DNA. Nuclear envelope, it encloses the cell and it is composed of two membranes. Nuclear pores, which is like a gate that allows the substances to get in and out from the nucleus. And now for the final and most important slide. It says, is the presence or absence of the nuclear membrane noticeable? Definitely it is. As the prokaryotes do not possess a nuclear membrane, their genetic material is floating in the cytoplasm of the cell. They also do not possess most of the organelles that are present in the animal or even in the plant cell, since most of the prokaryotes are bacteria. While on the other hand, the eukaryotes consist as cell structures since they do possess a nuclear membrane. Thank you all for your time. I hope you enjoyed my presentation. And now for Rital Al-Harbi, who from grade 7, who presented the 7-Up project. And now for Darina Al-Gahtani from grade 8, who presented the evolution of mobile phones, supervised by Mrs. Arij.
Hello and welcome to this presentation. Today we'll be speaking about the evolution of mobile phones created by student Darina Al-Gahtani. Where did it all start? Motorola was the first company to produce a handheld mobile phone. On April 3, 1973, Martin Cooper, a Motorola researcher and executive, made the first mobile telephone call from handheld subscriber equipment, and that was the start of the infamous mobile phone evolution. Mobile phone brands. Mobile phone brands started to pop up after seeing Motorola's first handheld mobile phone.
Jenna Al-Thani from grade 4, who presented how to make an instrument out of a cup, supervised by Mrs. Naha.
How to make an instrument out of a cup. You're going to be needing a cup and a rubber band or something else it can hold it with. Well, I don't want to use a rubber band. I found this rubber band, so I'm going to be using it. You can use it as a drum, or you can do this, and you can hear the sound of it. It sounds just like a guitar. I'm going to be doing another instrument. You put the cup like this, and you tap on it like a drum. This is my project. Bye!
And now for Lura Al-Amoudi from grade 9, who presented the speed of an object project, supervised by Miss Ariba.
Hello! The distance covered is 90, and the time is 14 seconds. So 90 divided by 14, the speed of the horse is 6.42 meters per second.
Haya Al-Agir from grade 10, which presented the project about the step counter with a microbit, supervised by Mrs. Haya.
Today I'm going to be showing you how to make a step counter on the microbit. First, we're going to create a variable and call it steps. Then we're going to set steps to 0 and put it on start. Then we're going to go to input, and then we're going to put on shake, change steps by 1. Basically, this means that whenever the microbit shakes, it's going to add 1 to the step counter. We're going to go to input and put on button A pressed. Then we're going to put show number of steps. Basically, this means whenever we click the button A, it will show us the number of steps we've walked. An extra little thing you can do is going to LED and put stop animation. This will basically cancel out the animation when you click button A. The final thing we're going to be doing is going to on button A plus B pressed, and then we're going to put reset. Basically, this means when we click both button A and B, it will reset the step counter. Now, how can we measure the distance we walked? You're going to want to make a function and call it distance. Then you're going to go return and multiply the measurement of your normal step times the amount of steps. In my case, my average step is 0.25 meters, but yours can be different. Also in my case, I'm going to be calculating the measurement in meters. To show the measurement on your microbit device, you're going to go into input and on button B press this time. Then you're going to go to show number and distance. Here is how your microbit should look like after running the code. I first clicked A to show that it starts at 0. Then I shook my microbit device as if I were walking. And I clicked A again and I walked 16 steps. Then I'm going to click B and I walked 4 meters. Then I clicked AB and it reset my device. Thank you for watching, and I hope you had fun coding.
And now for Urjuwan from grade 11 with her project about making a parachute supervised by Miss Ariba.
멈춘 시간 속 잠든 너를 찾아가 아무리 막아도 결국 너의 곁인 걸 결국엔 여행을 끝내 이젠 돌아가 너라는 집으로 지금 다시 way back home.
Maithil Amri from grade 12 with her project sensitive step counter supervised by Mrs. Haya.
Hello everyone, in this project I'm going to show you how to measure your steps accurately using the accelerometer sensor. So first of all, I attach the microbit to my shoes, and then I'm going to walk to see how the microbit counted my steps accurately. After several steps, I'm going to press the button A to see how many steps that I've walked, which is 7. By pressing these two buttons, A and B, the number of the distance will be shown on the LED display. And to find the distance, the microbit will multiply the number of steps, which is 7, by 30 meter, which is the length. And 30 multiplied by 7 should be 210 meter, which is correct. Create the sensitive step counter. I'm going to use make code for microbit application. In this program, it uses more accurate accelerometer readings of forces to decide whether to increase the step counter by 1. So here on start block, I'm going to create I created two variables, and we need to use variables in programs to store the information that can change. So when our program starts running, I want to set the steps and the length to 0, and the number 0, it will show in the LED display. So here in the forever block, there's an if statement, and it is an input acceleration block. The accelerometer can measure forces in 3 dimensions called the X, Y, and Z axis. I chose the X axis, which will measure from left to right. It should be greater than 100, and 100 is the threshold. You need to make the step more accurate when you add the number in the threshold. Whereas in the Shaycaster, the threshold has been decided by the people who designed for the microbit. So when the acceleration is greater than 100, it will change step by one and will show the number of steps. Then it will clear the screen. When on button A pressed, it will show the arrow pointing at the west direction. It will pause for 1 second. It will clear the screen. Then it will show the number of steps. It will pause for 3 seconds. It will clear the screen. Whereas here in the button B is pressed, it will show the arrow pointing in the opposite direction, which is in the east, and then it will reset. When the program is reset, that means it will set the steps and the length back to 0. Here on the shake gesture, it will change the length by 30, which means that when I walk, it will change the length by 30. Here when on the button A and B are pressed, first of all it will clear the screen, then it will show the arrow pointing on the west and east direction, and it will pause between them for about 15 milliseconds. Then it will clear the screen. Then it will show the string the. It will pause for 1 second, d, which means the distance. Paused for 1 second, then the show string again is, then it will pause for 50 milliseconds. Then to show the number, which is the product of the steps and the length, which is the distance. Then it will pause for 2 seconds to show the string meter, which is the unit. Then it will pause for 3 seconds. Then here in loop, it will repeat 2 times, show, let. But between them it will pause for about 50 milliseconds. Now to download your code to the microbit, you need to use the microbit USB cable. Then you connect it. Then you need to press the download button here, and the code will be downloaded successfully into your microbit. Creating Computer Graphics by Ghala Al-Ghamdi from Grade 10, supervised by Miss Haya.
My project is about how to draw this shape on small basic using the turtle function. This is the code that I've used for my program, and I'll explain each line as we go. The second line is setting a background color for the program. The third line is setting a pink color, or the color of the shape. The fourth line is setting a pen width. I wanted my shape to be a little thick, so I set it as 5. For the fifth line, I wanted the turtle to be hidden as it draws the shape. The sixth and the seventh line is setting a point for the turtle to start drawing at, and line 8 is just setting a speed for the turtle to draw at. Lines 10, 11, 12, and 13 are functions for the turtle to do. The number of sides is for drawing the shape. I wanted to draw an octagon, that's why I set it as 8. The repeat count is how many times the shape is supposed to rotate, and I want it to rotate for 8 times to form the shape that I wanted. The side length 1 and side length 2 are the length of each polygon, and I made the second length half of the first one. The first for loop I used here is the number of rotation. I set I for 1 to repeat count, and J for 1 to number of side, which draws the first polygon. Turtle moves side length, so it forms the shape of the first polygon as 100 length for each side. The turtle turns 360. The turtle turns to 360 degrees, and it draws an octagon of 8 sides. Sorry. The second for loop here is it draws the second polygon, basically the same as this, but instead of 100 on each side, it's going to be 50 as mentioned here. And then here, the last 3 lines is for turning the turtle to prepare for the next round, as you can see here. And when you run the code, the shape is being drawn by the turtle, as you can see.
Lulu Al-Amoudi from grade 9, which presented Newton's first law supervised by Miss Ariba. Static electricity made by Liana Al-Wigdani from grade 10, supervised by Miss Ariba. Soda can experiment made by Maytha Al-Amri from grade 12, supervised by Miss Arisha. Antivirus software made by Hannah Baghdadi from grade 6, supervised by Miss Arij.
What are antivirus softwares? Bahana Baghdadi, grade 6C. What are antivirus softwares? Antivirus softwares are programs that keep viruses away from our electronics. How do antivirus softwares help us? 1. They help us avoid viruses. 2. They help us keep our work safe. 3. They also help against hackers. And finally, they help us avoid info leaks. Here's a video made about antivirus softwares. Hello everyone. My name is Ava. And today I'll be talking about antivirus softwares. I'll be showing you pictures of those softwares and also recommend a few. First, let's start with the pictures. Now the recommendations. And there you have it. Bye. I have also included the Google version of the explanation. Antivirus is a kind of software used to prevent, scan, detect, and delete viruses from a computer. Once installed, most antivirus software runs automatically in the background to provide real-time protection against virus attacks. I hope you liked it.
And now with Amal's Matar project from grade 12, supervised by Miss Araisha. Density of liquids made by Rinat Kutbi from grade 7, supervised by Miss Araisha.
Good morning everyone, I am Rinat Kutbi from grade 7C. Today we will do 5 layers of density of liquid. So we should have a cup of water, and we should have honey, and we should have a down dish soap, and we should have oil, water, and sanitizer. First we will put some honey. Okay, so we put it some honey. Then we'll put that down dish soap. We should put it very gentle. Don't mix with the honey. Like you are seeing, now we have 2 layers. This is the honey and this is the soap, the down dish soap. Then we will put the water. Very gentle because we have a soap here, so it should be very gentle when you are putting the water. Okay. Then we will put the oil. Very gentle, of course, we put it. Okay. Then we will put the sanitizer at last. Very gentle. Like you are seeing, the first layer is honey. This is honey, and this is the soap, the down dish soap, and we have above it the water, then the oil, then the sanitizer at least. Okay, like you are seeing. Thank you for seeing the experiment about the 5 layers of density, and I wish that you benefit from the experiment, and see you soon.
And now for the digestive system made by Jana Saati from grade 12. This project is about the human digestive system, done by Jana Saati. She used Play-Doh to demonstrate the different organs of the digestive system, including stomach, small intestines, and large intestines. And now for the animal cell structure made by Lin Attar from grade 10. Lin used the clay to demonstrate the different organs of the digestive system, to demonstrate the cell nucleus and different cell organelles. Cell structure by Lina Al-Jihani from grade 10. She used the clay to demonstrate her model of the animal cell. As you can see, the shapes of each organelle that expresses the actual animal cell. And now for my own project, which is about creating a digital thermometer supervised by Miss Haya. What is a microbit? The BBC Microbit is a pocket-sized computer that introduces you to how software and hardware work together. It has an LED, light display, button sensors, and many input-output features that you can program and physically interact with. How can it detect temperature? The microbit shows how hot or cold the temperature is by taking a reading from the temperature sensor in its processor or CPU. When you press input button A, the microbit displays the processor's current temperature on its LED display output. Is it possible to convert the temperature from Celsius into another degree? Yes, it is possible by using convert C to F function, for example. You can change the form of the function in order to get the temperature in different type of temperature degree. But in this case, you have to change the conversion formulas for the type of temperature you're going to have. Here is mine as an example. This is the conversion formula from Celsius to Fahrenheit. And this is another example, but for converting the temperature from Celsius into Kelvin. As you can see in here, both buttons show the temperature 21 Celsius, but in Kelvin, which is 294.15. And this is the conversion formula from Celsius to Kelvin. Thank you for watching. Bye. Thank you all for watching. We achieved so much in the time we've been here and gained a lot ourselves too. This event is finished. Of course, but it doesn't really stop here. Until soon, be time to be thinking about organizing the next one. I know I've enjoyed today enormously, and I hope you all have too. Don't forget to vote for your most favorite project. Result will be announced on Thursday, January 28th.